Hello everyone and welcome to this interesting session on deep learning with Python. Let's have a quick look at the agenda of this session. So I'll start off this video with an introduction to artificial intelligence, machine learning and deep learning and how they are related in terms of data science. Moving forward, we'll learn a little bit about AI and ML and understand how machine learning failed, which brings us to the main topic of this session, that is deep learning, and we'll understand how it overcame all the problems that machine learning faced. Next, we'll discuss some important applications of deep learning and see some really cool applications that are too good to be true. Now, moving forward, we'll learn what exactly is a neural network and understand the structure of a perceptron and see how a neural network behaves. And towards the end, we'll create our own perceptron from scratch using Python. And I'll finish off this video by creating a neural network in Python to show you guys how exactly deep learning works. Now, deep learning is a hot buzz nowadays and has firmly put down its roots in a vast multitude of industries that are investing in this field, like artificial intelligence, big data, and analytics. Now, for example, Google is using deep learning in its voice and image recognition systems, whereas Netflix and Amazon are using it to understand the behavior of their customers. In fact, you won't believe, but researchers at MIT are trying to predict the future using deep learning. Now imagine how much potential deep learning has in revolutionizing the world and the way we work around things. Now, before talking about deep learning, one must understand its relationship with machine learning and artificial intelligence in terms of data science. So if you have a look at the picture here, you can see that the data science is the superset, and inside we have artificial intelligence, inside that we have machine learning, and inside that we have deep learning. So data science is an extraction of knowledge from data using different techniques and algorithms, whereas AI or artificial intelligence is a technique which enables machines to mimic human behavior. Now, machine learning is a subset of artificial intelligence technique which uses statistical methods to enable machines to improve the experience, whereas deep learning is a subset of machine learning which makes the computation of multi-layer neural network feasible. It uses neural networks to stimulate human-like decision making. Now, the term artificial intelligence was coined in 1956 by John McCarthy, who is also referred to as the father of artificial intelligence. The idea behind AI is fairly simple yet fascinating, which is to make intelligent machines that can take decisions on their own. Now, you may think of it as a sci-fi, but with respect to recent developments in technology and computing power, the very idea seems to come closer to reality day by day. Now, if you ask me, AI is the simulation of human intelligence done by machines which are programmed by us. Now, the machines need to learn how to reason and do some self-correction as needed along the way. Now, the way we have detailed algorithms which artificial intelligence systems can make use of, they can perform huge tasks faster and more efficiently. Now, machine learning and deep learning are just ways to achieve artificial intelligence. Now that you are familiar with artificial intelligence, let's talk briefly about machine learning and understand what it means when we say that we are programming machines to learn. Here I have a famous quote by Tom Michel of Carnegie Mellon University. He says a computer program is said to learn from the experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. Now this might seem a little confusing, E, P, and T. So if you want your program to predict the traffic pattern at a busy intersection, let it be the task T, which I'm talking about. You can run it through a machine learning algorithm with data about past traffic patterns, that is the experience E. Now, the accuracy of the prediction, which is the performance measure P, or the prediction, will depend on the fact that whether the program has successfully learned from the dataset or not, and the dataset being the experience E. So basically, machine learning is referred to as a type of artificial intelligence that provides computers with the ability to learn without being explicitly programmed by exposing them to vast amount of data. Now, the core principle behind machine learning is to learn from the data sets and try to minimize the error or maximize the likelihood on their predictions being true. Even though machine learning had great advancement, there were some drawbacks of machine learning. So traditional machine learning algorithms are not useful while working with high dimensional data. That is where we have large number of inputs and outputs. For example, in case of handwriting recognition, we have a large amount of input where we have different types of input associated with different types of handwriting. Now, handling and processing such types of data becomes very complex and resource exhaustive. This is termed as the curse of dimensionality. Now, to understand this in simpler terms, let's consider the following image. Now, consider a line of 100 yards, and you have dropped a coin somewhere on the line. Now, it's quite convenient for you to find the coin by simply walking on the line. This very line is a single dimensional entity. Next, consider you have a square of 100 yards, and yet again you drop the coin somewhere in between. Now it's quite evident that you are going to take more time to find the coin within the squares as compared to the previous scenario. Now this square is a two-dimensional entity. Let's take it a step ahead by considering a cube of side 100 yards. Now you have dropped a coin somewhere in between. Now it's even more difficult to find the coin this time. The cube is a three-dimensional entity. Hence, you can observe that the complexity is increasing as the dimensions are increasing. And in real life, the high-dimensional data that we are talking about has thousands of dimensions that makes it very complex to handle the process. Now, the high-dimensional data can easily be found in use cases like image processing, natural language processing, and image translations. Now, machine learning was not capable of solving these use cases. Now, the second major challenge is to tell the computer what are the features it should look for. That will play an important role in predicting the outcome as well as to achieve better accuracy while doing so. Now, this very process is referred to as feature extraction. Feeding raw data to the algorithm rarely ever works, and this is the reason why feature extraction is a critical part of the traditional machine learning workflow. Therefore, without feature extraction, the challenge for the programmers increases as the effectiveness of the algorithm very much depends on how insightful the programmer is. Hence, it is very difficult to apply these machine learning models or algorithms to complex problems like object detection, handwriting recognition, and image processing. Now, here comes deep learning to the rescue. Now, deep learning is capable of handling the high dimensional data and is also efficient in focusing on the right features on its own, which is the process of feature extraction. So before we understand how exactly deep learning works, let's have a look at the applications of deep learning. So the first application of deep learning is speech recognition. Now, all of you might have heard about Siri, Cortana, or the Google Assistant. Now, Apple has also started investing on deep learning like the other big giants to make its services better than ever. In the area of speech recognition and voice-controlled intelligent assistant like Siri, one can develop more accurate acoustic model using a deep neural network and is currently one of the most active fields for deep learning implementation. In simple words, you can build such systems that can learn new features or adapt to you, therefore provide better assistance by predicting all the possible beforehand. Next on our list, we have automatic machine translation. So, we all know that Google can instantly translate between 100 different human languages, and that too very quickly as if by magic. The technology behind Google Translate is called machine translation and has been a savior for people who cannot communicate with each other because of the difference in speaking of language or because of some language barrier. Now, you would be thinking that this feature has been there for a long time, so what's new in this? Now, let me tell you that over the past 2 years, with the help of deep learning, Google has totally removed the approach to machine translation in its Google Translate. In fact, deep learning researchers who know almost nothing about the language translation are putting forward relatively simple machine learning solutions that are beating the best experts built language translation systems in the world. Text translation can be performed without any pre-processing of the sequence, allowing the algorithm to learn the dependencies between words and their mapping to a new language. Stacked networks of large recurrent neural networks are used to perform these kind of translations. Next, we have instant visual translation. So as you know, deep learning is used to identify images that have letters and where the letters are on the scene. Once identified, they can be turned into text, translated, and the image recreated with the translated text. This is often called instant visual translation. Now imagine a situation where you have visited any other country or any other place whose native language is not known to you. Well, no need to worry. Using various apps like Google Translate, you can go ahead and perform instant visual translation to read the signs or the shop boards written in another language. Now, this has been possible only because of deep learning. Now, if we talk about automated self-driving cars, it's not something which isn't there. It's very well there and people are using it. Now, Google is trying to take their self-driving car initiative known as Waymo to a whole new level of perfection using deep learning. Therefore, rather than using old-handed coded algorithms, they can now program systems that can learn by themselves using data provided by different sensors. Deep learning is now the best approach to most perceptron tasks as well as to many low-level control tasks. Hence, now when people who do not know how to drive or are disabled can go ahead and take the ride without depending on anyone else. Now, if we talk about predicting the future, what deep learning does is that it can help us in predicting the earthquakes, tsunami beforehand so that the preventive measures can be taken to save many lives from falling into the clutches of natural calamities. Another implementation of deep learning is the chatbots. Now, all of you have heard about Siri, which is Apple's voice-controlled virtual assistant. Believe me, with the help of deep learning, these virtual assistants are getting smarter day by day. Now, chatbots also work with the help of deep learning. Now, if you might have used any of the online ordering apps like Amazon or Flipkart, you might have gotten. If you have ever visited or used the customer care services of any online or e-commerce website like Amazon, Alibaba, or in fact Flipkart, the customer care service to which you are interacting with might not be an actual human. So that is where chatbots are heavily implemented, and also in the transportation apps like Uber and Ola. Now, these chatbots can adapt itself according to the user and provide better personalized assistance. Now, there is a very cool application of deep learning which is the Google AI Eye Doctor. It is a recent initiative taken by Google where they are working with an Indian eye care chain to develop the AI software which can examine retina scans and identify a condition called diabetic retinopathy, which can cause blindness. Now, if we talk about artificial intelligence and deep learning in general, there is a dream reading machine. Now, this is one of my favorites, a machine that can capture your dreams in the form of video. With so many unrealistic applications of deep learning we have seen so far, I was not surprised to find out that this was tried in Japan a few years back on 3 test subjects and they were able to achieve close to 60% of accuracy. That is something quite unbelievable, yet true. Now, let's move ahead in this deep learning tutorial and understand how deep learning works. Now, basically, deep learning mimics the way our brain functions. That is, it learns from experience. As you know, our brain is made up of billions of neurons that allow us to do amazing things. Even the brain of a 1-year-old kid can solve complex problems which are very difficult to solve even using supercomputers. For example, recognizing the face of their parent and different objects as well, discriminating different voices, and even recognizing a particular person based on his or her voice, draw inference from facial gestures of other person, and many more. Actually, our brain has subconsciously trained itself to do such things over the past years. Now the question arises, how deep learning mimics the functionality of a brain? Well, deep learning uses the concept of artificial neurons that functions in a similar manner as the biological neurons present in our brain. Therefore, we can say that deep learning is a subfield of machine learning concerned with algorithms inspired by the structure and function of the brain called artificial neural network. Now let us understand the functionality of the biological neuron and how we mimic this functionality in the perceptron or an artificial neuron. Now if we focus on the structure of a biological neuron, it has dendrites which is used to receive the inputs. Now these inputs are summed in a cell body and using the axon it is passed on to the next biological neuron as shown in the above image. Similarly, a perceptron receives multiple inputs, applies various transformations and functions, and provides an output. Now, as we know that our brain cell consists of multiple connected neurons called the neural network, we also have a network of artificial neurons called perceptrons to form a deep neural network. Now, one can categorize all kind of classification problems that can be solved using the neural networks into 2 broad categories. One is the linearly separable problems, and the second one is non-linearly separable problems. So basically, a problem is said to be linearly separable if you can classify the dataset into 2 categories or classes using a single line, for example, separating cats from other groups of cats and dogs. On the contrary, in case of non-linear separable problems, the dataset contains multiple classes and requires non-linear line of separating them into respective classes. You guys might be familiar with AND gates. I will be using this as an example to explain how perceptron works as a linear classifier. So as you know, AND gate produces an output as 1 if both the inputs are 1 and 0 in all the other cases. Therefore, a perceptron can be used as a separator or as a decision line that divides the input sets of an AND gate into two classes. Class 1 inputs having output as 0 that lies below the decision line, and second class is inputs having the output as 1 that lies above the decision line or the separator. Now the diagram here shows the above idea of classifying the inputs of AND gate using a perceptron. So till now you understood that a linear perceptron can be used to classify the input data set into two classes. But how does it actually classify the data? So mathematically one can represent a perceptron as a function of weights, inputs, and bias. Now each of the input received by the perceptron has been weighed based on the amount of its contribution for obtaining the final output. Now bias allows us to shift the decision line so that it can best separate the inputs into two classes. Now enough of this theory, let us look into the example of the perceptron learning algorithm where I will implement the AND gate using a perceptron from scratch. So for this purpose I am going to use Python. A few important things to note here that there are certain deep learning frameworks that can be used to achieve the solution. So there are TensorFlow, we have Theano, we have PyTorch. So what I'm going to do is use the most famous framework, which is TensorFlow, and I'm going to use Python for programming here. What you need to do is install TensorFlow. We have another tutorial on TensorFlow in which we have shown the exact steps to how to install TensorFlow and what exactly is TensorFlow. So I'm not going to go into the details of that. So first of all, what we need to do is I'm going to use the Jupyter notebook here to do all my coding. So created a Jupyter notebook called Deep Learning with Python. So first of all, what we're going to do is we're going to import all the required library. So I will begin with importing all the required libraries. And in this case, I just need to import one library, that is TensorFlow. So what I'm going to do is now import TensorFlow as TVF. So once we have imported TensorFlow, now what we're going to do is define the vector variables for the input and output. I'll create the variables for storing the input and outputs and the bias for my perceptron. So here I have the training input and here I have the training output. So as you can see here, we have the training input and the training output. So now what I need to do is define the weights variable and assign some random values to it initially. Since I have three inputs over here, input 1, 2, and the bias, I will require three weight values for each input. So what I'll do is I'll define a tensor variable of the shape 3 cross 1 for our weights that will be initialized with random values. Now, one thing important to note here is that in TensorFlow, variables are the only way to handle the ever-changing neural network weights that are updated with the learning process. Now next what we're going to do is we're going to define the placeholders for input and output. Now in TensorFlow, you can specify placeholders that can accept external inputs on the run. So I will define two placeholders, X for input and Y for output. Later on, you will understand how to feed inputs to a placeholder. Now, as discussed earlier, the input received by a perceptron is first multiplied by the respective weights, and then all these weights inputs are summed together. Now this summed value is then fed to the activation for obtaining the final result as shown in the image below. Now I'll show you the code of how to do this. So guys, as you can see here, in this case I have used the relu as my activation function. So there are a lot of other activation functions like the sigmoid function, the relu, we have the crelu. Other important activation functions will be introduced as you proceed further. Now that I have used relu function as my activation function, I need to calculate the error value with respect to the perceptron output and the desired output. So generally this error is calculated as the mean squared error, which is nothing but the square of the difference of perceptron output and the desired output. So this will be our loss. Now, another thing important here to note is that what we need to do is minimize the errors. So TensorFlow, the deep learning library, provides optimizers that slowly change each variable, that is the weights and the biases, in order to minimize the loss in successive iterations. Now, one of the most simplest optimizer available here is the gradient descent or optimizer, which I'll be using in this case. So guys, if you want to know more about the gradient descent optimizer and how exactly a neural network works, go check out the gradient descent video which is posted by Edureka, the link to which I'll share in the description box below. So in case if you want to know more about the mathematics, the exact mathematics of how the gradient descent works, and what exactly is the purpose of a perceptron when we are talking about minimizing the error, you can check out that video. So as you can see here, I have used the gradient descent optimizer. Now next step, what I'm going to do is initialize the variables. So another important thing to know down here is that the variables are not initialized when I use the tf.variable method. So for that, I need to explicitly initialize all the variables in a TensorFlow program using the following code. So as you can see here, I have init, and I'm going to use the tf.globalvariables._initializer. That will initialize all the variables that I have placed under the tf.variable. So let me run it. So now I need to train our perceptron, that is, update the values of the weights and bias in successive iterations to minimize the error or the loss, which is our main goal. Now, one important thing to note down here is that when we talk about deep learning models, there are certain hyperparameters to work on. So, for example, we have epochs, we have the learning rate. As you learn more about deep learning, how the neural network works, what are the other possible parameters or the hyperparameters used. Moving forward, if you learn about the convolution neural network or the recurrent neural network, you'll learn there are a lot of other hyperparameters involved there also. So here I've just used the epoch, which is the number of iterations which I'm going to do to train this particular model. So for me, the epoch is 1000. So I'm going to use for I in range of 1000. I'm going to run this session and calculate the cost. And let's see exactly what's the output of this model. As you can see, we already have the output and it's increasing 100, 200, 300, 400, 500, 600, 700. And finally, as you can see here, we already have the output here till 999 epochs. So as you can see here, if we start from the first epoch, you can see the loss is 1.03. It became 1.02, 1.00. It came down to 0.98. And the more we train the particular model, the more it will understand the particular data set, and the loss will decrease as long as we train the model. If we have a look at the loss at the 999th or the 1000th step, as you can see, 1000th epoch, so the loss is 0.0003. That's an amazing loss. And since our data was so small, it was very easy for the perceptron to learn the data during the 1000th iterations because there's nothing new about AND gate. But the complications arises when we are dealing with large amounts of data in which the data is of high dimensionality and each data differs from the previous one in some other respect. So this is how you create a perceptron using Python. In TensorFlow, you can use other deep learning frameworks as well, which work with Python via PyTorch. So this was a single perceptron on which we did the coding and understood how exactly it works and mimics the human neuron which takes on decisions. So as I mentioned earlier, our brain has a network of these neurons which is known as the neural network. So let's move ahead with this deep learning video to understand how a deep neural network looks like. So as you can see in the image above, deep learning works as follows. At the lowest level, the network fixates on patterns of the local contrast as important. Now the following layer is then able to use those patterns of local contrast to fixate on those things that resemble eyes, nose, and mouth. Finally, the top layer is able to apply those facial features to face templates, and a deep neural network is capable of composing more and more complex features in each of the successive layers. Now, one important thing here to note down is that we have not explicitly mentioned what to look for. So this is one of the amazing features of deep learning, is that it automatically attracts the features which are important for the dataset to categorize the photos, the videos, or whatever be your input data. So have you ever wondered how Facebook automatically labels or tags all the persons present in an image? So well, Facebook uses deep learning in a similar fashion as stated in the above example I showed. Now you have realized the capability of deep learning and how it can outperform machine learning in those cases where we have very little data, very little idea about all the features that can affect the outcome. Therefore, deep neural network can overcome the drawbacks of machine learning by drawing inferences from the dataset consisting of the input data without proper labeling. Now, let's understand another deep learning use case. So now if we talk about this example of this image recognition, here we are passing the high dimensional data to the input layer first to match the dimensionality of the input data. The input layer will contain multiple sublayers of perceptrons so that it can consume the entire input. The output received from the input layer will contain patterns and will only be able to identify the edges of the images based on the contrast level. This output will be fed to the hidden layer 1, where it will be able to identify various face features like eyes, nose, ears. Now, this will be fed to the hidden layer 2, where it will be able to form the entire face. Then the output of layer 2 is sent to the output layer. Finally, the output layer performs classification based on the result obtained from the previous and predicts the same. Now, let me ask you a question. What will happen if any of these layers is missing or the neural network is not deep enough? Now, the answer to it is very simple. We will not be able to accurately identify the images. Now, this is the very reason why these use cases did not have a solution all these years prior to deep learning. Just to take this further, we will try to apply deep learning networks on the MNIST dataset. Now, the MNIST dataset is a very popular dataset which consists of around 100,000 training samples and 10,000 testing samples of handwritten digits. Now, the task here is to train a model which can accurately identify the digits present in the image. Now, to solve this use case, a deep network will be created with multiple hidden layers to process all the 60,000 images pixel by pixel. And finally, we will receive an output. The output layer will be an array index 0 to 9, where each index corresponds to respective digit. Index 0 contains the probability of 0 being the digit present on the output image. So guys, if you want to dig deep into a neural network and want to know how exactly this MNIST dataset works, Edureka has another video on this artificial neural network and how exactly it works on this particular dataset. So I'll leave the link to that video in the description box below. Let's get ahead and understand how exactly we can code this in Python. So first of all, what we're going to do is from future import the print function. So what it will do is it will help us in reducing the errors which are caused by version mismatch, and it helps a lot when you are coding in deep learning because every now and then we have another deep learning framework or we have new frameworks and libraries coming up which creates a problem while we are working with old data or old data sets, and MNIST being one of the earliest big data, or what we can call it as a huge data set. So working on it might create a little bit of problems while working in Python. What we need to do is use the future import print function. So next what we're going to do is import the MNIST data. Now we can import the MNIST data if you have it saved in your PC, but what TensorFlow does is that it provides certain examples and tutorials, and inside that we have the data of MNIST. So what I'm going to do is import it from tensorflow.examples.tutorials. So next what I'm going to do is import TensorFlow STF and import matplotlib, which is the Python library for plotting the plots. We're going to use the matplotlib.pyplot. So as you can see here, we have a certain warning, but there's not an error just because we use the from future import print function. Once we have imported TensorFlow and matplotlib, so next what I'm going to do is initialize the parameters, which are the learning rate, the training epochs. We have the batch size of 100. So here I'm going to take a batch size of 100 because initially you need to train it with a small example and then move forward. Like you can change the batch size to 1000 and 10,000, but it will delay the process of learning. These things you have to keep in mind is that the hyperparameters which I'm talking about are the learning rate, the training epochs, and the batch size. These all need to be calculated and be taken care of by you. And that is where most of the data scientist roles comes in. So the major role of a data scientist is to decide the value of these parameters, how exactly to initialize these variables so as the model would be perfect to run. Next, what I'm going to do is initialize the network parameters. So in the image earlier, we saw that we had two hidden layers, one input layer, and we have one output layer. What I'm going to do is create two hidden layers which have 256 number of perceptrons. This number is arbitrary. You can use any number of perceptrons in a particular single layer. It depends on you. For input layer, I'm going to use 784 input because the image shape is 28 into 28 and that equals 784. So it will be 784 pixels. And the output classes or the output layer, which will be 10, because as you know, the MNIST tool classes are 0 to 9, which are 10 digits. So let me initialize this for you as well. I'm going to use the network parameters here. So as you can see here, I've even mentioned it in the code here as the first layer of number of features 256. So as you can see, the MNIST data input of the image shape, the size of the image is 28 into 28 pixels, which makes it 784. So that will be our input layer, the number of perceptrons in the input layer. So after that, what we're going to do is create a TensorFlow graph, and we're going to use the placeholders X and Y we're going to create. So one is for the input, one is for the output, the placeholders. Now, next step, what we're going to do is create our model. So for that, what we're going to do is create the hidden layers. So if we have a close look at the definition of this multi-layer perceptron, so that we have the input X, we have the weights and the biases. So the layer 1 in which we have the matrix multiplication of X into the weights and the biases. And then again, we are applying the NN, which is the tf.nn, which is the TensorFlow.NeuralNetworks.relu. You can use sigmoid, you can use any other activation function which you want to get a different result. For this practical, I'm going to use the relu activation function. So similarly for layer 2 also I'm doing that, and for output layer also, but then again in the output layer we are not using any activation functions. There we're going to do only the matrix multiplication. So one thing here to notice is that for the layer 2 the input is layer 1, and for the output layer the input is layer 2. We need to store the layer weights and biases. So for that, we're going to create the weights and biases for each of these particular layers. So here we have H1, H2, and out, which are the weights for these H1, H2. We have the biases. So next what we're going to do is construct a model, and we're going to use the multi-layer perceptrons in which we have the X as the input and the weights and biases. And we're going to name this as PRED, predict. So next, our step is to define the loss and the optimizer. So as I mentioned earlier, when we are talking about perceptron, so the main goal is to reduce the cost. So we're going to use the tf.reduce mean function here. And inside this, what I'm going to use is tf.nn.soft max cross entropy with logist. So if you have a close look here, I'm going to use the tf.reduce means so that we can reduce the cost. We're using the neural network softmax cross entropy function here, and for optimizer we are using the Atom optimizer. It's up to you. You can use the gradient descent optimizer as well as any other optimizer for training the data and training the models. So what you can see here, we are providing the learning rate, and in the optimizer we're going to use the function called minimize so as to minimize the cost using the particular optimizer. So as you can see, we have a small warning, major versions mismatch. That's cool because it's not creating any error as of now. So once again, what we're going to do is initialize all the variables. So we're going to use the tf.global_variable initializer. Then again, we're going to create an empty list to store the cost history and the accuracy history so as to get a track of whether our deep neural network is working in the right direction or not. So don't get afraid when I show you this code. What we're going to do is launch the graph which we created. So for that, we're going to use tf.session as scss. And then we have the training cycles for epochs in the range training epochs. So epochs, which we mentioned earlier, are 15. So we're going to train this for 15 epochs. First of all, what we're going to do is create the average cost as 0. But what we're going to do next is that loop it over all the batches. So the batch size is 100. We're going to use a batch size of 100, iterate it for 15 epochs. For I in range total batches, we're going to MNIST.train the next batch size. Next, what we're going to do is run an optimization backdrop and the cost operation to get the loss value. We're going to calculate the average cost, and then finally we'll calculate the accuracy. So What we're going to do is accuracy will be tf.reduce mean of the tf.cast of the correct prediction. What we're going to do is now append the accuracy to the list. And next what we're going to do is append the cost to the list also. So as the final output, we get the accuracy and the cost, and we'll see how the accuracy increases while the cost decreases. And then again, we have the plot the cost history to just have a look at the plot of what the cost looks like and the accuracy looks like. So let me run this code. So as you can see, in first epoch, we have cost 171, accuracy 0.8. Second epoch, the cost has reduced to 41 from 171. So you can see we have already reached the accuracy of 0.92. On the fifth epoch, it's 0.925. So as you can see here, as the cost is decreasing, the accuracy is increasing, because that's the main goal of any deep neural network, is to decrease the cost and increase the accuracy. So till epoch 8, you can see it's 0.93 and the cost has reduced to 5 now. The hyperparameters, what we talked about, the epochs, batch size, and if we talk about the number of perceptrons in the layers, these parameters should be chosen wisely, and that is where the experience of a data scientist comes in, as in the data scientist has an experience, and this thing can only be achieved with lots of practice. So as you can see here, the optimization has finished, and you can see the first graph here is of the cost. So it initially started with 171 and it came down all the way to 0.9. And as you can see, at the same time, the accuracy started from 0.86 and it has reached all the way to 0.947, almost 0.95, that is 95%. So guys, this is it for today's session. I hope you guys came to know what exactly is deep learning, how artificial intelligence, machine learning, and deep learning are connected in terms of data science as we speak, how artificial intelligence is a subset. Now, machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning, and how exactly a perceptron works, the idea behind a neural network mimicking the human brain, how you can create your own perceptron from scratch, how you can create a neural network from scratch using Python and the other deep learning frameworks. So guys, that's it for today's session. I hope you enjoyed this video, and if you have any queries regarding this video or in general, please leave it in the comment section below and we'll revert to it as soon as possible.